This video I want to show this little device. It's a band-stop filter for the FM broadcast station from 88 to 108 megahertz. It's got two female SMA connectors. Put a couple of adapters there to BNC. I originally bought this filter for this radio because back in the days I was living in Rome, in a big city, and there were a lot of repeaters from the FM broadcast stations, from many stations. So I've got all sorts of they obviously they transmit with a lot of kilowatts, and I was getting a lot of intermodulation problems, and also desensitization of the radio. I was mainly interested in listening to aeronautical bands, 118 to 136, 137, and also on some services below the FM spectrum from the broadcast stations, about 74 to 79 megahertz. So the receiver, this receiver with an external antenna, would suffer a lot, and in fact I was not able to properly receive. Actually, some signals disappeared, even with the attenuator on. I had no way to listen to those signals in the right way. So yeah, I found this on eBay, and I was sure. Well, actually, first of all, I did this. I think I made another video on YouTube. I built myself this rudimental notch filter with some caps and some coils, and I saw the results. Okay, I saw the results, and actually it was helping a lot. The receiver was working back again. So yeah, I thought I'd give it a go, and I found this on eBay for 20 euros, more or less, and I bought it. Inside, I'm not gonna open it again because I just did it, but I was filming, but I had some issues with the orientation of the camera, so I'm doing this again. But yeah, without opening again, basically there's a small board and some SMD components, as you would expect, some capacitors and inductors to have the right frequencies, cutoff frequencies. Yeah, so let's have a look now at how it behaves. Okay, so the device is now connected between the two ports. So we'll go on RF test, and yeah, RF test, and yeah, we go on and activate the tracking gen. We are with the reference, and the middle is 98 megahertz, which is the center band of the FM broadcast, and the signal coming out from this port is minus 10 dB, and is get into this port. So let's have a look. 10 megahertz per division. So we start at 48 megahertz up to 148 megahertz. Yeah, let's have a look. Activate the tracking gen. There we go. So as you can see, can actually reduce the span a little bit. As you can see, if we go with the markers to have a look, here 773, we have a little bit of attenuation. I was interested in those days, not anymore, but in those days I was interested in these frequencies up to 79 megahertz. There are a couple of services there. Yeah, as you can see in the top edge of those frequencies, I have about 5 dB, 4.5 dB of attenuation, which is acceptable. And then it goes down quite a bit, and we reach 88 megahertz here, and we are already 46 dB down, 47 dB down. So that's a very a good attenuation. We continue on to the other side, and we reach 108 megahertz. Still same attenuation, and then we rise up again. Now the aeronautical band starts here, 118, and here we have 10 dB of attenuation, which is still, you know, 10 dB is 10 dB. It's 10 times the power. So at the beginning, we've got a little bit of attenuation there. So, and then as you can see, we reach a point at minus 3 dB, about here, 123. So the first 5-6 megahertz of the aeronautical band are a bit attenuated, but I don't remember this to be an issue with me. I used to have an antenna on the roof of the building, and I was able to receive all the transmissions with no issues, even on at the beginning here. I remember there are a couple of tower frequencies, you know. So yeah, it could have been a bit better on this side. And before, between 118 and 108, so on the side of the band stop filter, there are the radio assistance for navigation for aircrafts. But anyway, not too much of an interest there. Yeah, that's it. So yeah, the filter has a nice shape. Yeah, so okay, once again, thanks for watching the video, and as always, I hope that's been helpful to somebody out there. All the best, 7-3.